What if the fate of Earth's future depends on secrets hidden over 1 million miles away? Imagine, for a moment, that the next chapter of human civilization could be determined not by events on our own planet, but by delicate forces at play far beyond our blue skies. Forces that, until recently, few even knew existed. Out past our familiar skies, there exist 5 peculiar places known as Lagrange points. At these locations, the gravitational pulls of Earth and the Sun are perfectly balanced. These aren't just random coordinates in space. They are the product of precise cosmic mathematics first described in the late 18th century. Imagine them as cosmic parking zones, spots where satellites can remain steady, barely burning any fuel. To grasp just how rare and valuable these spots are, think of balancing a marble on the tip of a pencil. In most places, the marble would roll off instantly, but at just the right angle, with just the right forces, it can rest in perfect stillness. That is the essence of a Lagrange point, a place where the tug of war between massive celestial bodies creates an oasis of stability in an otherwise turbulent universe. Take the James Webb Space Telescope, for example. It quietly observes from L2, a gravitational haven sitting about 1.5 million kilometers from our planet. This is not a convenient accident. It is the result of centuries of mathematical insight and technological ambition. These are not just trivia for space enthusiasts. These delicate points are why billion-dollar missions can survive, protected by unseen forces at the edge of space. But here's the twist. If we overlook the lessons of these cosmic balances, we risk more than losing machinery. We could forfeit opportunities to safeguard our planet, or miss innovations that might decide the very fate of civilization. Throughout history, civilizations have risen and fallen based on their ability to recognize and respond to balance points. Think of the way Roman engineers maintained their aqueducts, or how early navigators read the stars for safe passage. Missing these moments of equilibrium has spelled disaster more than once. But how do these mysterious points really work, and why have they become so vital to our explorations and hopes for the future? Let's peel back the layers of this cosmic puzzle. What if hidden pockets in space held the secret to our technological future, and your own? Picture places where gravity and motion perfectly counterbalance, letting objects remain almost motionless amid the swirling chaos of the cosmos. These are the elusive Lagrange points. Discover them, and you could unlock the next revolution in both space and earthly technology. Overlook them, and you risk losing billions and missing out on progress itself. In every corner of our solar system, whenever 2 massive bodies, say the Earth and the Sun, share an orbit, there are exactly 5 special locations called Lagrange points. At each, gravitational forces and orbital motion blend into zones of equilibrium, like cosmic parking spaces where satellites can rest with almost no fuel or effort. These are not just physics trivia, they are the difference between mission triumph and disastrous failure. Let's travel back to 1772. Joseph-Louis Lagrange, a mathematician working in the Age of Enlightenment, published a paper describing the mathematics behind these points. It was a revolutionary idea, one that would not come to full fruition for more than a century. But today, every major space agency, from NASA to the European Space Agency to JAXA, designs missions with Lagrange points in mind. Why? Because a third, much smaller object placed at a Lagrange point can hover in near-perfect balance, needing only minimal energy to stay put. The most stable, called L4 and L5, allow satellites to maintain their positions for years, barely sipping fuel. Consider the James Webb Space Telescope once more. It circles the second Lagrange point, L2, about 1.5 million kilometers from Earth. Here, Webb enjoys an unbroken view of the universe, steady solar power, and constant contact with our planet. This is only possible because L2 offers a razor-thin equilibrium. Miss it, and missions could lose millions, precious data, or vanish entirely. This is not the first time humanity has depended on finding the right balance. In the early days of human flight, the Wright brothers achieved powered flight not by brute force, but by finding the precise balance point between lift, drag, and gravity. Similarly, the Apollo lunar mission succeeded because engineers calculated the delicate balance needed to escape Earth's gravity, enter the moon's orbit, and return home safely. In each case, a small miscalculation could have led to disaster. Overlooking these cosmic sweet spots comes at a steep price. Satellites in unstable orbits risk drifting away, burning up, or failing, taking with them invaluable communications, climate records, and scientific discoveries. That is not just lost hardware or money, it is lost opportunity and perhaps even lost progress for humanity. In 2009, for example, a communication satellite drifted from its intended position and had to be abandoned, costing hundreds of millions of dollars and leaving a crucial gap in global connectivity. Lagrange points are far more than scientific curiosities. They are crucial tools that protect our technology, propel innovation, and secure our future in space and here on Earth. Mastering these points is mastering balance itself, safeguarding investments, powering breakthroughs, and reducing costly mistakes. If cosmic balance can create such stability, can these same secrets help us spot and respond to tipping points, threatening our own planet's delicate equilibrium? Let us look closer at how the logic of cosmic balance might reveal new ways to identify and even prevent catastrophic shifts here on Earth. The clues are hiding in plain sight. Picture the future of Earth balanced on a razor's edge. Imagine a world where missing a single crucial equilibrium could send everything spiraling out of control. This is no idle thought experiment. The stakes are the fate of the entire planet. Out in the vastness of space, Lagrange points are rare, invisible sanctuaries. These are the cosmic parking spots where gravity and motion cancel out, creating islands of stability. Find one and a satellite can hover almost effortlessly, using almost no fuel to remain fixed, just as the James Webb Space Telescope does. There are only 5 such points between the Earth and the Sun, each one offering a haven amid the universe's constant turbulence. In stark contrast, Earth's own systems, our climate, forests, and oceans, are teetering on the brink. Scientists warn that we are hurtling toward critical tipping points, thresholds where even a tiny nudge could unleash runaway, irreversible changes. In space, balance means calm and predictability. On Earth, losing balance could mean catastrophe, massive loss of life, vast economic ruin, and the undoing of centuries of progress. What does a tipping point actually look like? Imagine the Amazon rainforest. Scientists warn that if a certain percentage of the forest is lost, estimated at around 25%, rainfall patterns could shift so dramatically that the forest could collapse into savanna, threatening millions of species and the livelihoods of countless people. Or consider the Greenland ice sheet. If melting crosses a certain threshold, it may trigger unstoppable sea level rise, submerging coastal cities worldwide. Environmental collapse is not a distant threat. It could strike with devastating speed if we ignore these warnings. Unlike satellites, our planet's stability is not automatic. It requires vigilance, creativity, and relentless commitment. But hope remains. Researchers at the University of Exeter urge us to engineer positive tipping points, targeted changes that can spark sweeping benefits for both society and nature. Their call is urgent. We must seek out those moments where small shifts can trigger large-scale solutions. Already, clean energy and electric vehicles are nearing thresholds that could flip entire industries towards sustainability. Let's look at some real, current examples. In the past decade, the cost of solar panels has fallen by more than 80%, making solar power affordable for millions. As adoption spreads, it becomes self-reinforcing. More installations mean lower costs, which in turn encourage even more adoption. In Norway, electric vehicles now make up more than 80% of new car sales,
a shift driven by smart policy incentives and public enthusiasm. These are positive tipping points in action, small, focused interventions triggering rapid, society-wide change.
The opportunity before us is enormous, but so is the peril. If we hesitate, we could trigger losses from which there is no turning back. If we act with purpose, we might find our own earthly Lagrange points, those rare, pivotal positions in technology and society that keep our future in balance. What exactly makes these cosmic equilibrium points so powerful? And how might their secrets help us tip the balance here on Earth? Let's explore the mechanics of Lagrange points and the surprising lessons they hold for our planet's future. Imagine a playground swing. When the swing reaches its highest point, a gentle push at just the right moment can send it soaring higher with little effort. But mistime the push, or apply it at the wrong angle, and you waste energy, or even stop the swing altogether. Lagrange points are like those perfect moments, places where a small, well-timed action can have outsized impact. What if a single, universe-inspired insight could change the fate of Earth, launching us toward breakthrough or sending us spiraling into disaster? This is not distant speculation. The world may depend on spotting the right leverage point before it slips away. Think of the perfect balance at a Lagrange point, a place in space where everything holds steady. Now, imagine recreating that clarity here on Earth. Could one well-timed innovation or policy act as a cosmic pivot, tipping our entire system toward lasting sustainability, just as satellites glide effortlessly between the Earth and the Sun? Scientists at Exeter University warn, if we miss these positive tipping points, we lose out on massive long-term environmental benefits. The stakes are real. In areas like clean energy and green transport, the right intervention at the right instant is already sparking transformation, proof that a small push can set off a cascade of change. This is not fantasy. Take the James Webb Space Telescope. By parking itself in a Lagrange point, it revolutionized astronomy, requiring almost no fuel to maintain its position. Imagine if your choices in technology or policy could have such a powerful effect. Maximum outcome, minimal waste, all here on Earth. Governments and investors are chasing this cosmic logic, investing billions. They search for stable, high-impact points, much like scientists plotting where to park a satellite. The payoff? Trigger a new era of progress. But miss by even a little, and we risk wasting decades, resources, and the planet's fragile balance. If we ignore these lessons, we may waste precious years on shaky solutions, losing our shot at a sustainable future. But act with the precision and timing of the cosmos, and we could spark the next wave of breakthroughs in climate, technology, and global policy. Whether you shape policy, invent technology, or simply care about our future, the question is clear. Will you act on this cosmic lesson before the window closes? But what exactly makes a Lagrange point so special? Understanding the science behind these cosmic sweet spots could reveal how to find similar leverage here on Earth. To understand the power of Lagrange points, let's get concrete. In the Earth-Sun system, L1 lies between Earth and the Sun. It is the perfect place for solar observatories, like the Solar and Heliospheric Observatory, which keeps a constant eye on solar storms that could disrupt our power grids. L2, where the James Webb Space Telescope is stationed, is ideal for deep space telescopes needing a cold, stable environment. L3 hides on the far side of the Sun, while L4 and L5 form equilateral triangles with Earth and the Sun, positions so stable that clouds of dust and even asteroids, called Trojan asteroids, have gathered there over eons. This precise positioning allows us to create space weather monitors, cosmic observatories, and communications relays that keep our planet connected and safe. If we missed these points, missions would require constant course corrections, burning through fuel and budgets. In 2021, the James Webb Space Telescope was launched with barely enough fuel for 10 years of operation. Only the stability of L2 makes this mission feasible for decades to come. You do not have to be a scientist to spark a tipping point or to find your own Lagrange spot. The logic behind these cosmic balancing points can help anyone ignite change, whether you are leading a movement or just making daily choices. The biggest breakthroughs often begin with a tiny, well-placed action. Scientists from the University of Exeter call these moments positive tipping points, when a single push triggers a lasting, powerful shift. Picture the first domino that starts a chain reaction, only this time, the wave moves in a direction that uplifts everyone. Space teaches us to use energy wisely. Spacecraft parked at Lagrange points, like the James Webb Space Telescope, conserve enormous amounts of fuel because gravity balances perfectly there. They remain steady with almost no extra effort. That is our metaphor for change. Act where the forces already meet and your influence multiplies. Every system, whether cosmic or close to home, contains these leverage points. Maybe it is a community needing a spark, a new technology on the verge of mass adoption, or a policy waiting for a handful of voices. The key is to spot these points and take action, even if the move feels small. Some positive tipping points, such as in renewable power and transport, have already begun, proof that focused effort works. But there is a danger. Miss these pressure points, and you may waste effort, burn out, or watch problems spiral. The good news? You are not powerless. With strategy and attention to balance, you can help tip the system too. But how do we find these leverage points in the messiness of real life? The answer lies in looking for patterns, just as astronomers do in space. Consider the shift from landlines to mobile phones. For decades, adoption was slow, but at a certain point, when costs dropped below a critical threshold, usage skyrocketed, transforming societies in a matter of years. Or take social movements. A single act of protest, broadcast to millions, can ignite sweeping change, as seen during the Arab Spring. The lesson? Tipping points are real, and they can be engineered. Miss the right balance, and you risk losing precious progress, resources, and even hope itself. But spot equilibrium in time, and you can unlock breakthroughs that ripple through history, just as the universe depends on its own fragile harmony. Lagrange points prove that, in the endless reaches of space, a single, precise location can decide whether we squander billions or open worlds of discovery. The James Webb Space Telescope lives at one of these rare spots, gaining matchless clarity and stability, advantages unthinkable anywhere else. On Earth, we face turning points just as critical. Researchers at the University of Exeter have shown how a well-aimed shift, like a bold climate policy or a leap in clean energy, can spark rapid, lasting transformation. Seize these moments, and you gain a chance to steer the future. Let them slip by, and you risk locking in harm for generations. The difference between leading change and being swept away comes down to finding leverage. Seek your own Lagrange point. A single action or idea placed just right, and you could ignite a wave of progress beyond anything imagined. So ask yourself, where is your point of maximum impact? Will you stand by, or will you become the force that tips the balance toward a better world? The universe's hidden geometry is not just a cosmic curiosity. It is a guide for anyone seeking meaningful change. What happens when we apply these lessons from the stars to the choices we make on Earth? Think of the Lagrange points not just as outposts in space, but as metaphors for human ingenuity. The very fact that we can identify, reach, and exploit these balance points speaks to our capacity for foresight and precision. Imagine a future where we apply the same careful calculation, the same relentless search for equilibrium to our social, technological, and environmental challenges. Practical steps are within our grasp. First, be alert to patterns of change, where small actions start to have outsized effects.
Whether in adopting solar panels, supporting new policies, or championing local initiatives, look for the moments when momentum shifts. Second, collaborate. Just as space missions rely on international teamwork, societal tipping points often require alliances across sectors and borders. Third, act with timing and precision. Remember the lesson of the swing or the satellite. Miss the window and the effort may be wasted. Act at the right moment and the effect multiplies. Finally, embrace the mindset of exploration. Joseph-Louis Lagrange's insights seemed abstract and impractical in his day, yet today they hold satellites steady and reveal the universe's secrets. The breakthroughs of tomorrow, be they in climate action, technology, or social progress, will come from those who dare to seek balance where others see only chaos. So, as you look to the heavens, remember, the forces that keep a telescope poised between worlds are the same forces that can keep our own world in balance. The next great tipping point is out there, waiting. Will we recognize it in time? And will we have the courage to act before it slips away forever?